All right, in our last video, we took a look at how to find the GCF of two monomials, or any number of monomials. We wanted to find the biggest number that you could divide out of each monomial, each term, but then we also wanted to take a look at how many variables could you take out of each term, whether it was x's or y's or whatever. And all of that was so that we could factor a polynomial like this using that GCF. So let's go back and do a quick review of what it means to be a factor versus a product. So we saw earlier this unit that a product is the result of a factor times a factor. For example, 40 is the product, 5 and 8 are factors of 40. And of course there's more than that, but 5 and 8 just happen to be two of the factors of 40. With a monomial, we saw that 21x squared can be the product or just the regular term, but you could factor that or break it into smaller parts like 3x times 7x, which gives you 21x squared. Now, if we look at an expression as being the product, like 20x squared minus 8x, we're trying to figure out what multiplies together to give you 20x squared minus 8x. And the way that we do that is we try to find a greatest common factor, so something you can divide out of both terms, and then we look at the rest of it as what's left over after you divide the greatest common factor out of those terms. So this is kind of what we're doing today. This is where we're heading with our answers. We're going to start with the product. We're going to try to figure out what the factors are. The key is going to be finding the greatest common factor of the original terms. So let's go back to our first example and start with, let's just find the greatest common factor of these two terms, the GCF of 12x to the fourth power and 9x to the third power, just like we did in the last lesson. So over on the side, I'm just going to show my work for finding the GCF of 12 and 9. And we just list your factor pairs. 12 can be written as 1 times 12, or 2 times 6, or 3 times 4. And that's it, because then you're back to 4 times 3, 5 doesn't go, and you're at 6 times 2, and eventually 12 times 1. With 9, it's really just 1 times 9 and 3 times 3. So the factors of 9 are just 1, 3, and 9. So which number is the largest common factor? 3. 3 is a factor in each of those coefficients, 12 and 9. So the GCF contains a 3, but then remember that we also have a bunch of x's in each term. So what's the most x's that they have in common? They each have at least 3 x's. So our GCF is going to also have x to the third power because there was x times x times x in each one of those terms. So our GCF is 3x squared. Now how we factor this is we kind of have a hint up above in blue. It says that we want to take the GCF, which is 3x squared, and write it as the GCF times whatever's left over. Okay, and what I mean by that is whatever's left over after you divide out the GCF. So we are going to take each term and divide by the GCF. That's going to give us what's left over after we take the GCF out of it. Okay, that's our division step. So this goes back to how do we divide exponential expressions, okay, expressions with exponents. So in this first part, we want to take the 12 and divide it by 3. Those are just regular numbers. And we see that 12 divided by 3 is 4. And then we also want to divide our powers of x. But I say divide powers of x, but what I really mean is use the law of exponents, which says subtract the exponents. Because remember, it would be like taking x to the fourth power divided by x to the third power, in which case we can cancel common factors, leaving you with just x to the first power, since 4 minus 3 is 1. We subtract because it's essentially like canceling. So that first one's going to have 4x to the first power left over, just going to bring down the plus sign from that original expression. And now we do the same thing to the second part. We divide out the greatest common factor, starting with the number parts. 9 divided by 3 is 3. And then x to the third power divided by x to the third power, well, that's just something divided by itself. And anything divided by itself is just 1. And we know that 3 times 1 is just 3. But what we're going to do is we're going to take our original expression, which was 12x to the fourth power plus 9x to the third power, and we are going to rewrite it as a multiplication problem. So we had 3x cubed was the GCF. That was what they had in common. And then when we divided out the greatest common factor, we were left with 4x plus 3. It's kind of like we just undistributed the problem. We can check our answer by distributing. If we were to multiply 3x cubed times 4x, we would get 12x to the fourth power. If we multiply 3x cubed times 3, we would get 9x cubed. So we're basically undistributed as a way of factoring this expression. So that is my answer. One of my factors is 3x cubed. That was the greatest common factor. The other factor then is 4x plus 3. I know there's two parts to it, but that's the other thing that we multiply by since it was grouped in parentheses. So I know this can be a little confusing. Let's look at some more. Okay, I think each time you see a problem worked out, you'll start to develop a pattern. So in number 2, I need to find the GCF. Okay, in order to factor a polynomial, so something that's 2 terms, I need to start by identifying what is the most I can divide out of either term, because that's going to be our next step. So starting with my coefficients, I have 15 and 25. I want to find the greatest common factor. So 15 has the factors of 1 times 15, and oops, I should put 3 first. 3 times 5, and that's it. 1, 3, 5, and 15. 25 is 1 times 25. And let's see, 2, 3, and 4 don't work, but 5 does. 25 divided by 5 is 5. So my greatest common factor is going to include 5 as the coefficient. And then you might remember this from yesterday when we wrote out all our variables. So y cubed times z squared, that was the first part. And then in my second expression, I had y squared and z to the fifth power. So what did we have in common? Well, they each had a y. Well, actually, they each have 2 y's, but that's it for the y's. And then, let's see, it looks like they each have 2 z's, but no more than that, because the first expression only had z squared in it. So for my GCF, that's going to be y to the second power, and then z squared also. So my GCF is 5y squared z squared, excuse me. All right, so that's step 1, find the GCF. Step 2, next we want to divide the GCF out of both parts, both terms. So we're going to divide by 5y squared z squared. I'm trying to line things up right underneath the other variables and constant numbers, because when we divide, we want to actually just divide straight down, right? Divide the like parts together. So we have 15 divided by 5. Then we're going to divide y cubed by y squared. And finally, z squared divided by z. So dividing, 15 divided by 5 is 3. For my y's, remember our shortcut, subtract the exponents. It's just going to be y to the first power. And for the z's, I can subtract the exponents. It's z to the power of 0. In other words, I don't have any z's left over. Z squared divided by z squared is just 1. It's right? Anything divided by itself is 1. The z's all cancel out. In my second part, I'll highlight again to make that match. And we'll just divide the coefficients, then divide the powers of y, and divide the powers of z by subtracting your exponents. So 25 divided by 5 is 5. Y squared divided by itself is 1. So, I mean, I could write times 1, but it seems kind of silly to do that. Since 5 times 1 will just be 5. And then z to the 5th power divided by z to the 2nd power is z to the 3rd power. Remember, that's our subtraction rule. Subtract the exponents, because it would be the same thing if we wrote it out and canceled them out. If I had 5 in the numerator, I canceled 2 of them. I'm left with z times z times z, which is z cubed, z to the 3rd power. So that is what we get when you divide out the GCF. So if we were to write this out as the actual problem, the multiplication problem that would give us what we started with, it is 5y squared z squared, that's our GCF, multiplied by the leftover part, 3y minus 5y, whoops, that should be 5z to the 3rd power. And that is our factored form of that original polynomial. All right, problem number 3. This time we have 3 terms, but we're going to do it the same way, same basic steps. We're going to start by finding the GCF of all 3 of these terms. So in terms of the numbers, 4, 6, and 8, we could list them out, or we can look at this and just recognize, you know what, the biggest number I can divide out of 4, 6, and 8 is 2. I can divide them all by 2, but I can't divide them all by 3 or 4 or 5 or 6 or 7 or 8 even. Just 2 is the greatest common factor of 4, 6, and 8. For the variables, you know, what is the most that they have in common? Well, I have x cubed, I have x squared, and I have x. Well, they all have an x. So my GCF contains an x as well, but only one of them, because that's all that's in the last term. So my GCF is 2x. That's what I need to divide out of all 3 terms. As we saw in the first couple problems, when you divide the coefficients. So 4 divided by 2 is 2. And 6 divided by 2 is 3. And 8 divided by 2 is 4. And in terms of the dividing the x parts, the variable parts, remember you're subtracting the exponents. So in the first expression, x cubed divided by x to the first is x squared, because it's like x cubed divided by x, cancel, you're left with x squared. In the second part, where we had the 3 after we divided, it's x squared divided by x. So x squared divided by x, cancel, you're left with x. And then in the last part, 8x divided by 2x, we ended up with 4 as we divided, and x divided by x will cancel out. So kind of like that. So we just left with the 4. So our leftover parts, 2x squared minus 3x plus 4. And that's when we multiplied it by 2x. The GCF goes out front. All right, last one. Last one. All right, this one, not quite as many terms in it. Maybe, again, you can do some of this without writing out your factor pairs of 9 and 12. I mean, you certainly could. But I know 9 and 12, the biggest number I can divide out of 9 and 12 is a 3. They're both divisible by 3, but nothing bigger than that. And then for my variables, I have m to the 5th power and m to the 3rd power. So I know that they each have at least m to the 3rd power in it. So that's what I want to divide out of each term. A 3m to the 3rd power. And when I do that, I divide the coefficients, but I subtract the exponents of the variables. So that first part divides out to be 3m squared. Bring down the subtraction. Divide on the second part. 12 divided by 3 is 4, and m cubed divided by m cubed is 1. Right? Anything divided by itself is just 1. So those are going to cancel out. So that's my leftover part. I just have to put my GCF at the beginning, and there it is. That's the factored form of that polynomial we started with.